Everyone, we're going to start our final revision to do with Unit 2 in preparation for your mock exam. Now, we're going to start with Unit 2 first because I've seen more people demand a revision about Unit 2 than Unit 1, and then we'll also make another video for Unit 1. Okay, I would like to divide Unit 2 when it comes to revising it into 3 sections. Relationships between quantities being one of them. Okay, the units and the formulas that you actually need to know in order for you to solve your equations. And the last section, I would like to keep it more about ideas themselves, such as alternating current, direct current, the types of wires that you have, all of this stuff. All right. And that will also include a little section to do with how do you solve electric circuits. Okay, let's start with the formulas and the fundamentals that you need to know formulas wise when it comes to solving this unit. Okay, the first formula your book mentions to you is the formula of calculating electric power, and it's basically current multiplied by voltage. What you need to know is that power is measured with watts, and current is measured with amperes, and voltage with volts. Okay. Now, the second formula you're going to face is that there is another way for you to calculate the power, and you know this one, which is power equals energy divided by time. We took this formula in many different, like it's here, it's also in chapter 4. So it's a very common formula telling you that power is always energy divided by time. We understood from our good study to chapter 4 that energy is measured in joules. Okay, power is still measured in watts, and time needs to be in seconds. Though, using this formula, the one that's displayed right here, I can rearrange it and make it look like energy equals power multiplied by time, which is another formula that you might use in this chapter, and there is no issue about it. All I did is I tried to take energy on a side on its own by getting rid of the time that's under it right here. How did I do that? It's divided in this side, so I need to take it to the other side as a multiply. Okay, and that's how you rearrange your formulas. Now, if you want to be fancy, there is another formula that you can add other than those two, which is energy equals current times voltage times time. And where did this formula come from? Basically, you told me right here that energy is power times time, so place the time here. And what's power? Power, if you define it, it's current and voltage. So instead of writing power, I just wrote current and voltage, and instead of writing time, I wrote time. They're really in the same position it is. Okay, that's just an extra formula just to make things easier on you. Those are the first formulas that you need, and sometimes you will face a question where it asks you about powers and energies. It's usually an easy question if you memorize your formulas, because there isn't anything tricky about it. Like the maximum trick it would give you is give you time in minutes or hours, and you need to change it to seconds, and that's it. Remember with me one more time when it comes to the units, energy is always in joules, current is always in amperes, voltage in volts, and time has to be in seconds. All right, those are the first set of formulas that we're introduced to in the unit. Secondly, you move to another section, okay, and the chapter afterwards starts explaining to you what's the electric current and what's the voltage. So the electric current, the one that we kept writing as I, is defined to be, okay, how many charges move every second. So even in the formula, it's charge divided by time. Because remember with me, in order for electricity to move, you need electrons, and we referred those electrons to be charges. So how many charges move in a wire every second? That's what the electric current is. Now, if those charges move empty-handed without anything and without them carrying anything at all, they're useless. So they need to carry some sort of energy. We defined this energy to be the voltage. What's the voltage? We said that the voltage is how much energy every charge carries. Okay? And that's literally the two main fundamentals when it comes to electric energy. When it comes to electricity, you just need current, which are charges moving around, but those charges need to carry something, and the thing that they're carrying is a type of energy we're going to refer to as the voltage. Okay, voltage is literally energy, but the energy of every charge. Okay, so it's not the energy that's happening in the entire wire. No, it's how much energy every charge carries with it. Your book writes the formulas in a different way, but I prefer writing them like this because they're easier to explain in the concept I have in my mind. But the way you might see them in the book, is energy equals voltage multiplied by charge, which is just rearranging, leaving energy on its side, on the side of its own, and multiplying those two together. Totally normal. Even this one, you see it as charge equals current multiplied by time. But even in a question where it asks you, oh, write me the formula connecting this and this and that, it's up to you to write them in whichever format or way that you want. After that, something else that's important that you guys need to take a look at is page 71 in your book. Please take a look at page 71. You will find diagrams there that show you different electric components. Okay, and you need to know them in case they are given in a question as something that's missing, or you are given a question where you're supposed to draw a circuit, or the entire question just asks you the simple idea of name component X or something like that, like the one we had in the final in the first semester. I'll solve that, by the way, in this sheet because a lot of you had an issue with it. All right. After that, you should move to the next idea we're going to talk about, which is dealing with series and parallel circuits. All right, I hope I have enough space here. Yes, I do. All right, you have two types of electric circuits in which you're going to have to know how to solve. Okay, number one, let me flip it to the other side. Number one is the series circuit. And the other one is what we call the parallel circuit. All right. You can tell the difference between them by shape, okay? Or it's just whenever you see two things that are like connected on the same wire, you instantly can tell that you're dealing with something that's in series. But if the two components that you have inside the circuit are separated by a junction of wires, where are three wires connected together, kind of like giving the wire a different way in order for it to move in, then that's what we identify as a parallel circuit. So this is the parallel, and this is the series. Okay, now when it comes to those two, because you understood how does current and how does voltage act, you also need to understand how do they operate when it comes to the series circuit and the parallel circuit. Let's start with the series circuit. The series circuit has a simple rule that says the current in the series circuit is the same everywhere. Okay. Meaning that if I give you the current right here in the question and I give you the value of it is 3 amperes, you can use this 3 amperes to solve anything. You can calculate anything here with the 3 amperes, calculate anything here, because it stays the same. The 3 amperes are going to move in, move here, enter this resistor, enter the other one, move around, continue moving until they leave and enter the battery again and come back again. So if you are given, or if you calculate the electric current anywhere on the circuit, you can use it to solve any part of the circuit with no issues at all. All right. And that's something you should keep an eye on. All right. Now, the second thing that you need to understand is in series circuits, the voltage gets split. And please understand with me that when I say it gets split, is that whatever the source gives you has to be divided between the components. Okay. So let's assume that the source was 6 volts. The components together added should be 6 volts. Meaning if one of them was 2 volts, you can instantly assume that the other is 4 volts, because 2 plus 4 give you the total of the thing, which is 6. All right. It's untrue, or sorry, it's a mistake if you assume that, or if you solve that one of them has 2 volts and the other one has 5 volts, for example. 2 plus 5 is 7, and the battery gives you 6, which doesn't make sense. Where did the other 1 volt come from? Okay, and it's also a mistake if you do it the other way around of saying that this one is 2 volts and the other one is only 3 volts. Because 2 and 3 are only 5, okay, while the battery has 6 volts, which means 1 volt just went missing, which can't happen, all right? You just need to understand that the voltage gets split in a way where whatever the source gives you, it needs to be divided between both resistances. It doesn't need to happen equally, okay, but it has to get divided between them. Whatever the source gives you will go to some component and to the other component with it as well, all right? And that's the main fundamental things you need to know when it comes to a series circuit. Lastly, though it's very rare for them to ask the question about this, if it asks you for the total resistance, all you need to do is add up all the resistances. Okay? And etc. depends on how many resistances do you have. All right, moving on to the parallel circuit. Okay, it has the opposite rules of the series circuit. In the series circuit, we said that the current is the one that gets, is the same everywhere, but the voltage splits. Here I want to tell you that the voltage is the one that's the same everywhere. Okay. And the current gets split. Okay. Now, what I mean by this is, imagine you have current coming out of the battery right here, and the current was 3 amperes. Okay, as soon as this current reaches a junction, some of it will enter this way, some of it will continue to go down there. Okay, because it's electrons flowing, and those electrons are going to reach a point right here, and they're going to have to, take a side, either go forward or go to the right. The way this happens is usually dependent on the resistance, the value of the resistance that's placed right here. So we don't need to worry about it. We're just doing a calculation, not investigating as much. So in this case, if there is 3 amperes coming down, let's say the 1 ampere entered this way, you can assume that the other 2 have gone down there. All right. That's no issue. You just need to know that it's the complete opposite of a series circuit, and in a series circuit it stays the same everywhere, therefore right here it gets split. Okay, now moving on to the second point, which is the voltage. When I tell you that the voltage stays the same everywhere, imagine if in the question I told you that the voltage of the resistor, this one, okay, imagine if I told you the voltage of it equaled 2 volts. You can instantly assume that this one is also 2 volts and the battery is also 2 volts. It stays the same everywhere. At any point, if you find the voltage, you can use it to solve anything else as long as you're dealing with a parallel circuit. All right, those are your rules. Take a good look at them. Don't forget them. You can't solve a question to do with electric circuits, either a series or a parallel, unless you know how the voltage acts and how the current acts. Okay, let's move on. Here, we're going to start solving questions regarding everything that I mentioned. Hopefully those 2 questions are enough, and if they're not, I'll try to add another one. Okay, let's start off with the question that I gave you guys on the previous final. Most people didn't solve it, so I had to include it right now to make sure that you guys understand how it operates. First of all, you have the first question, which is give a name of a component, which is the component Y right here. You can find these in page 71 of your book, and there are many components, and you might always face a component that's unknown, so you need to actually memorize how the diagrams of them are drawn. Okay, and that's like a mistake you shouldn't do, because it's very possible for them to bring such questions in these scenarios. And the name of this component that's displayed in front of us is a variable resistor. Okay. Take a second look at page 71 and you'll understand what a variable resistor is, but it's a resistance that you can change the value of. Okay, we describe them as the ones that have like a knob, and you can spin this knob around by increasing it and decreasing it. So you can make the resistance more or less depending on what you actually want. All right. Give a reason to why component Y is included in this circuit. And right here, we're going to have to start explaining the relationships between quantities that I spoke about. Look here. Your main 3 components inside an electric circuit that you need to always keep an eye on are the current, okay, the voltage, and the resistance. Okay, now you need to understand how do they work together. For current and resistance, they're like enemies. Whenever the resistance is high, the current becomes low. Okay, so resistance, when it gets higher, resistance is basically an idea of you limiting how much current can go through. So if you do resistance too much, no current will be able to enter. All right, so if you increase the resistance, the current will always become low. And if you increase the resistance too much, the current will become 0. All right, now the second relationship you need to understand is the relationship between the voltage and the resistance. When you make the resistance high, the voltage automatically becomes higher. Why? Because you're making it very difficult for the current to move through, so it needs more energy to move through, and the energy we always refer to it as voltage. Those 2 connections you need to keep, and there is an obvious one that current and voltage are directly proportional, because if there is no current, there is no electricity, therefore there can't be voltage. And the other way around, if there is a lot of current, there is a lot of electricity, and voltage also increases with it. Those 3 relationships, you should know them. The most important one being this one, because it determines whether or not you understand resistance or not. If there is high resistance, current can't go in. If there is no resistance, current flows in very easily. Second one, if resistance exists, then automatically voltage starts going higher. And on all of these, the resistance is the one controlling. Okay? It's the one that increases the current and decreases depending on its existence or not. And lastly, the current and the voltage being directly proportional. Now look here at this question. It says, give a reason to why component Y is included in the circuit. It's a resistance, but the special thing about it is that it's a variable resistance, meaning that you can change the value of it as much as you want. You changing the value easily does one thing, which is control the current in the circuit, because if you make the resistance high, then the current becomes low. So in this case, you're limiting the current. No current goes in. But if you make the resistance low, a lot of current will enter. All right. And all of it, remember with me, all of this current enters right here. Okay, and it also moves in like on this ammeter. So it changes the readings here. It changes the readings on the voltmeter right here. So you controlling the current can do a lot of stuff afterwards inside the circuit. All right, let's move on to the next question right here. It says you have a graph and it shows some of the students' results. Okay, the graph puts a comparison between the current and the voltage right here. All right, and looking at this graph, you can see that the more the current increases, the more the voltage also increases. All right, let's answer the questions about it. State the formula linking charge, current, and time. We all understand that the charge is current multiplied by time. If you want to write it as current equals charge divided by time, it would also work. All right, and then the next question asks you to determine the current of in the lamp when the voltage across it is 10 volts. In order for you to solve that, you need to look at the graph, because it's a comparison between voltage and current. When the voltage is 10 volts, I'm talking between the number 8 and 12, right here, right in the center between them. This is where the 10 would occur. You need to make a straight line until you touch the graph up here, and then a straight line to the left. And you will know the exact value of this would be 0.48 amperes. Okay, and that's the number that you need to put right here. Okay. Lastly, it says calculate the charge transferred through the lamp in 30 seconds when the voltage across the lamp is 10 volts and give a unit. All right, you're going to calculate the charge, okay, which is current multiplied by time. Charge, in this case, is going to equal to you the current of 10 volts. When the voltage was 10, we said that the current is 0.48, and here it said it's 10 volts, so we need to use this current right here. 0.48 multiplied by the time, which is given to us as 30 seconds. Okay. If I remember correctly, it's supposed to be 14 point something. Yes, 14.4. And the unit for charge is coulomb, a big C capital. Don't forget about that. Okay. This is the unit for it, is something that we call coulomb. Okay, calculate the time for the lamp to transfer to 50 joules of energy when the voltage across the lamp is 10 volts. Okay, since it added energy, we're going to use the formula of energy. The formula of energy says power multiplied by time. Okay, or there is the shortcut one, which is energy equals current times voltage times time. This one is easier to use in such question. All right, so we can go straight up and use this one right here. In order for us to use the formula, energy is given to us as it's given to us as 250 joules equals the voltage is 10. The current when the voltage is 10 is 0.48. Okay, and we're trying to calculate the time. So the current is 0.48, the voltage is 10, and the time, I can just write the letter T because I don't know what it is. All right, multiply those two together. It's going to give you those two together. It's going to give you 4.8. And T next to it. On the other side, we have 250. All we need to do is take this to the other side as a division. Therefore, the time is 250 divided by 4.8. Okay, just need to do that in the calculator real quick. And it gives you 52 seconds, approximately 52 seconds. It's 52.08 something. Okay, the student disconnects the cell and reconnects it with terminals reversed. Complete the graph to show how the current in the lamp varies with the voltage across the lamp when the cells. This is a tricky question right here. Okay, basically he disconnects it as mentioned on top and he connects them in reverse, meaning that instead of the current moving in this way, it will start moving in that way. And remember with me, current, voltage, all of those are all vector quantities, which means they have a value and a direction. So in vector quantities, when something is going forward, we refer to it as positive, and when it's going backwards, we refer to it as negative. They will keep the same values because it's the same battery, but what will happen is instead of these values occurring in forward, they will start occurring in backwards, meaning that the exact shape you had on the graph, it will get repeated, but this time it will get repeated on the negative side. All right, sorry, let me fix the line, because right here, instead of the current being 0.48 positive in the 10 volts, it's supposed to be 0.48 negative on the negative side, like right here, something like that. Okay, so you just need to repeat the drawing, but you need to repeat it in the negative side. Look, all the voltages here are negative, all the currents right here are negative, and the reason this happens is because instead of the current moving forward, and we always assume forward is positive, right now we flip the terminals, which means it's going to move on the opposite side. Like instead of it at first going in this way, now we're going to flip it, making this one the longer side and this one the shorter side, so the current will start moving in this way. It keeps the exact same values. It looks like a mirror, the one that we drew right here. It keeps the exact same values, but it moves in the opposite direction. All right. Last question, it says the student replaces the filament light bulb, the filament lamp with a light emitting diode, an LED, this one, okay, with an alternating current power supply. This one is no longer a battery or a cell, no, it's an alternating current power supply, shown in diagram 2. The student also removes the ammeter and voltmeter from the circuit. Explain why the LED flashes on and off in this circuit. Focus with me for 1 second, okay. First of all, diodes in general, a diode is a type of resistance that only allows the current to flow in one direction. Okay, meaning this diode, if the current comes from this way, it will let it go through, no problem, talking about the electric current. But if the electric current comes from the opposite way, let me do that in red to show you that it's not right. If the electric current, oh, my bad. If the electric current comes from the opposite way, right here, it would not let it go through. Okay, so think about it as a gate that only allows electricity to flow from one direction. Now, what happens in such scenario right here when he connects the diode right here when he puts the diode right here, the diode just makes sure that the only electricity allowed to enter is the one coming from the right direction, the green one. If electricity comes or the current comes from the red direction, it's not going to let it go through. What an alternating current source does is it basically doesn't have a certain direction or a value, meaning sometimes it sends current this way, and then after a few milliseconds, it sends it in the other way around. Okay, so remember with me, if you study from your book on page, let me find the page number for you to refer to. Page 56 at the bottom, you will find the section talking about alternating current. It defines it as a current that does not have a certain, we can say that it's a current that keeps changing value and direction. What does changing direction mean to us in such case? It might go forward and it might also go backwards. Okay, so it keeps going forward, backwards, forward, backwards, forward, backwards. The idea is, let's analyze both scenarios, okay, and you'll understand what I'm trying to say here. So when it actually moves forward, okay, when it moves forward this way, the current will keep going, traveling, no problem. It will enter the resistance, no problem, and it will reach this point. Now, this diode only allows current to go forward, right? So it will go forward and checks, no issue at all. The light bulb inside the diode, because it's a light emitting diode, will flash. It will turn on. So everything checks out, no problem. But after a millisecond, when it sends the electric current backwards from the opposite direction, now it will stop going this way. No, it will start going in the other opposite direction, which is this way. The current will go through. It will travel the entire wire with no issue. As soon as it reaches here, will it be able to enter? No. Therefore, the light that was flashing a few moments ago will turn off. The light that was flashing on the light emitting diode will no longer work, and it will instantly flash off. All right, and that's literally what keeps happening. When the current comes from this way, it enters and the light flashes. When the current comes from the opposite way, it doesn't enter, therefore the light doesn't flash and it stops right here. And that's how it operates in this case. So in order for you to explain why does the diode flash and on and off, you just need to explain that alternating current is a current that moves forward and backwards because it keeps changing direction. And the light emitting diode is a device that only allows current to move in from one direction. In this case, we're referring to the direction as forward. And that would give you the answer to this question. Okay. All right, we're gonna continue to this question right here. It says diagram 1 shows a circuit built by a student. You have a battery on top right here, and then wires, and then a parallel circuit connecting two resistances in parallel is displayed in front of you right there. Okay, you have the amount of current going in here, the amount of current going in here, the resistance of this one, the resistance of this one. It's very easy to solve because it gives you too much information here. State the formula linking voltage, current, and resistance. Voltage equals current multiplied by resistance. Okay. Calculate the voltage across the 17 ohm resistor. Go to the 17 ohm resistor right here. Okay, you know the amount of current that enters it, which is 83 milliamperes, and you know the resistance it has. First of all, change the 83 milliamperes into amperes. Divided by 1000. Okay, and that would give you the answer of 0.083 amperes. Okay, and then second of all, since you've already settled that, you just need to multiply it. The formula says voltage equals current times resistance, as you know. Okay, and therefore it equals 0.083, sorry, multiplied by the resistance, which is 17. Do that in the calculator. The answer you would get is 1.411 volts. Okay. State the voltage across the 6.2 resistor, and you would not be the smartest man alive if you actually multiply them, because remember, this is a parallel circuit. All right, and because it's a parallel circuit, we calculated the voltage right here to be 1.411 volts. That means here it's also 1.411 volts. That means it's in the battery also 1.411 volts. Again, you obviously can multiply the current and the resistance and get it again, but that's like a lot of time wasted. You know, it's a parallel circuit, so the voltage is the same everywhere. We calculated it in one place, it's gonna be the same. Calculate the current in the battery. Very easy. The current comes out from here as a total current, and then it reaches this point right here and it gets split. Some of it enters here, some of it enters there. So in order for us to get the total right here, we're gonna have to add this one plus the current that went down there. So 83 milliamperes plus 228 milliamperes. Okay, so we just need to add them up together. And the answer that we're gonna get is 311 milliamperes, and that's the total current right there. B. Diagram 2 shows a second circuit built by a student using the same battery and resistors. Instead of connecting them in parallel, like the first time, he connected the two resistances in series. Okay, explain how the current in the battery will change now that the resistors are connected in series. You do not need to know any calculations. You do not need to do any calculations in your answer. So take a look at the circuit right here. Now the question is asking you what change will happen to the current, and always changes in such questions are either an increase or a decrease that you need to determine. In order for us to understand what's going to happen to the increase or decrease of the thing, we need to understand what happens to these resistances when they're connected in series instead of parallel. Okay, we understand that there are two ways to add resistances. Okay, the first way that we can use to add resistances is in series by simply adding them up together. So the total resistance here would be this one plus that one, so 17 plus 6.2. But if we go on the first scenario right here, they are connected in parallel. We cannot add resistances in parallel. What you need to understand when it comes to resistances connected in parallel, they always have less value. Okay, like I'm talking about the total value. If you connect two resistances in parallel, they're always gonna feel like they are less resistant than connecting them in series. And that's a piece of information that you should add up to your knowledge right now, okay? Now, based on that, you can simply answer the question, because when you connect resistances in series, they have more value, or they are stronger than when you connect them in parallel. Okay, and we all understand that there is a relationship between current and resistance. The relationship is pretty simple. When resistance is high, the current instantly becomes low. Now, when you connect resistances in series, the resistance is always higher than when you connect them in parallel. When you connect two resistances in parallel, the resistance is always weak. All right, so based on that, you can tell, since connecting two resistances in series makes them stronger than they are when they are in parallel, then you can tell that when the resistance is gonna be stronger now, the current will change and it will become less. Okay, and that's the change that would occur to it. So you just need to explain that to the question. Let me write the answer on the display here. All right, so here I stated that when resistances are connected in series, the total resistance increases as they add together. Resistance and current are indirectly proportional. This increase in resistance will result in a decrease in current, because when you connect them in series instead of parallel, the resistance will become more. And when the resistance becomes more, the current instantly becomes less, because it's more difficult for it to move through the wire. All right. Those two questions are very good to revise your basis when it comes to these. And then you can check the sheet that I'm also going to send on a message with the link to this video, the one that we already solved before in the first term, and you can practice. If there are any questions from there that you might have lost the answer to, or you don't understand them even by looking at them right now, send me a message with the question itself, as we will do inshallah tomorrow a live session that we can discuss anything that you did not understand properly, either from the videos or something that you struggle with, or if there is a question that you don't see the way to answer clearly, or whatever it is. Thank you guys for watching, and see you next time.